into play, and using metrics as a shared language to minimize some of those challenges. So a couple notes before we start though. This talk is really about applying data-driven concepts to Flink and other stream processing development processes. So although I'll be talking a lot about metrics, this is not going to be a tutorial about how to get started, because there's a ton of really good resources on that. So I can link to those at the end, and I'm also happy to share those with anyone who's interested in learning more. And additionally, I think it's important for systems to be provider agnostic if they can when it comes to metrics, because if the product that logs, tracks, analyzes, alerts on your data goes down, it would be really nice to have a backup system. So maybe this is a JSON API and you can query that. That's just kind of part of your system. So if the worst happens, you have that redundancy in your monitoring and logging as well. So for this reason, I'm going to try to keep myself provider agnostic for this. So you'll see metrics from various different monitoring and alerting providers here. And although many developers just use the dashboard UI that comes with Flink, which is great, when I first started using Flink, this was a huge selling point for a reason. I do still recommend pairing this with other observability providers. At my last company, we used the Flink UI almost exclusively just for tracking jobs, task managers, and other elements related to the status of the application. However, Flink also already has a really good REST API integration as well. So that makes being provider agnostic a lot easier. I've included a couple examples here from the current 1.11 release that have some of the main default categories included here. So I think I just picked like one from each. So for instance, requesting metrics for a specific entity, aggregated metrics by type, either for all entities or for a subset. There's of course tons more there. Additionally, Flink has reporters for popular external observability providers like Datadog, Prometheus, and all of that makes this even easier. So there's a lot of great docs on this already. So that's why I'm not going to be covering it too much in depth here, but they are super cool. And I want to make sure and give them a shout out here. So briefly, those data-driven basics and kind of how I'm going to be using some of these terms. So if you Google the title of my talk, maybe not the pun version, but the subtitle, you probably notice that there's a lot of terms, a lot of different interpretations, and a lot of opinions on all these terms. And if you search for data-driven development, you'll mostly find information about business metrics and data-driven design. There's a big overlap between these two, as essentially the main focus here is to use data to drive the design of a product that customers might actually want to buy and use. So it's important to note the differences though, because that's going to change how you use your metrics and who's using your metrics internally, which the more complicated you get, which of course is stream processing and using really powerful frameworks like this, is going to be more and more important to keep that distinction in mind. Business metrics refer to anything related to internally measured success. So this is like team velocity, sprint burn down, lead time. Business metrics can also include what a lot of people refer to as vanity metrics. Vanity metrics often include things like we're putting 3 million messages through a day, and those things are great and intended primarily though for things like press releases, blog posts, etc. Data-driven design relates specifically to the end user experience. As the name implies, the main focus here is to use data, typically data involving usage patterns and user feedback, in order to better understand and design for the needs of that user. Data-driven development is kind of often just lumped together with these or used as an umbrella term. Honestly, I think it can still be appropriate as an umbrella term, but the focus here is going to be where it represents metrics that are targeted at changing the development process itself. And that's what I'm just really excited to talk to you about, because it's kind of essential to look at this on its own in order to really leverage it properly. Secondly, there's a set of principles that come more directly from data-driven design, but honestly, I think are pretty relevant to all these areas. And it's this idea of this three-tiered approach that defines the type of metrics that you use and how they guide your product, but they're categorized by their relationship with quantitative or qualitative data. We've got data-driven design, which is centered purely around quantitative data. This process is applicable to aspects of the software design, like optimization, performance. As you progress outwards, the next thing you have is data-informed design, which weighs and utilizes qualitative and quantitative data equally, usually together to make a design decision. And furthest out is data-aware design, which typically is focused more directly on that qualitative information. But of course, the quantitative analysis is still often used as a base or to pair with customer use stories, detailed feedback, or discussion-based risk-reward analyses. Now, I know a lot of this is probably very familiar to us, especially if we're in data analytics or big data realms here, but I think there's just so many different interpretations. I wanted to get super clear about kind of where I'm coming from on this. So this category is also often thought of as one that kind of takes that bigger picture into account. And that's why this diagram is often expressed like a circle, kind of like this. So I actually really like using both diagrams. I thought I was going to get further than this without having to have too much water. But so I really like this one in particular because it shows that wider scope where it progressively takes more types of data into account. So this is also important to say, because this will come up later, that typically development styles in the center tend to be easier to automate. And of course, the further you go outwards, the more manual processes will probably be more necessary. This is also relevant, particularly in how to share metrics effectively with different internal teams and groups as you get closer and further from the engineering team that's on the center of this diagram. So as for the stream processing specific challenges, some of these are just the inherent challenges that we see commonly with stream processing that we're all probably pretty familiar with. The fact that you're just dealing with unbounded streams of data. So this is going to be a little more challenging the more powerful and more complicated framework you have, because of that potential for the just extremely high throughput, going through top speed, risking issues like back pressure, heavier consequences for things like memory leaks. Of course, if your framework is stateful, then there's going to be additional risks with memory, any memory issues, as well as heightened risk for losing state, as of course most of the recovering system is based on being able to access this properly and in real time. Additionally, though, you could have a simple streaming pipeline with only one source or sink, or that's consuming directly from the source. But one of the reasons we use stream processing is typically because we want something that can compensate for a really complicated system. So you're much more likely to have what we've probably all been using here, multiple data streams, possibly being joined at the point of ingest. And also the data you're consuming will likely have already undergone transformations, possibly done by applications upstreaming you that you may not have control over. So it's also likely that, as I said, having those merged data streams, that having these multiple streams means that you could have data coming in multiple different formats that have very different high throughput rates and everything. So common scenario, however, full coordination with upstream and downstream teams, particularly in relation to metrics, tends to often be very overlooked. So that's kind of what I want to talk about here. And overall, the biggest challenge with this type of architecture that I've seen is that relationship between an application that's in this situation and with the technical ecosystem around it, and how this changes so drastically when you're with a streaming application, and of course, the more complicated you get with that. Okay, integration points tend to be much more complex, and I'll be going into that a bit later, and really about kind of like structuring metrics around those points and how to keep those metrics meaningful without a lot of hassle, and when multiple different groups and teams can be sharing any one integration point. So now we can move on to metrics-driven metrics. What do you measure to know what to start measuring? Where do you get started? And how do you know what the right metrics are? I know, right? So first though, of course, you have to start somewhere. And on that most basic level, of course, the best place to start is keeping it as simple as possible, proofs of concepts, playground applications, starting that small cycle and letting it grow with the growth of your application's development. In addition, whichever framework you choose will have its own recommendations for specific key components to measure. However, within this, it's easy to get lulled into just measuring what's recommended, which is where good data-driven development practices come in. And later I'll have some examples where these situations, where this metrics-driven metric cycle has really drastically altered how we measure these components. And that's why I really wanted to kind of nail down those basic concepts, because it really gives you that leg up for being able to stay flexible when your streaming app inevitably gets more complicated and just a little bit weird. So I love this dashboard because I think it's a great example of really labeling exactly what's important to track. And it includes a pretty full list of the metrics that I want to start with for any example Flink application here. And of course, for any other streaming applications would be finding similar components as well. So as I mentioned, the UI that's included in Flink already has a lot of this information, including how many jobs are running, restarts, basically everything you see in this column here. And on my last engineering team, we decided that separating out the application status by using the Flink UI and our own monitoring platform separately really was a time saver for us, and really continuing to use both of those especially as we use the Flink UI as part of our deployment process. But for many people, especially if you're going to be sharing this with other teams, it can be helpful to duplicate that actually and have that here as well. And one thing I really like about this dashboard in particular is that you have several complementary pieces of each thing that you're measuring here. So for instance, the checkpointing, having this all in one place, you've got the failed checkpoints as a single number, which of course is useful. But combining this with that last checkpoint over a span of the last several hours is going to be a lot more impactful. Over here, we got resource utilization. And this is particularly useful for Flink as a lot of these operations are very dependent on the JVM heap. However, resource management for any stream processing framework it's going to be pretty important to have this here. So finding a version of that for that is important as well. And then the rest of these I'll cover in a moment. So beyond the specific components you want to measure with stream processing, when it comes to knowing where to start and what metrics are going to be valuable to you, I found that trying to have one single answer to these questions is actually kind of ineffective. So instead, I was much more successful in framing this as a process, having that be an ongoing iterative practice of really knowing your normal. So the main components of this practice are pretty simple: focusing on what's meaningful, staying iterative, and keeping it accessible. As for keeping your metrics meaningful, starting with some good basic dashboard hygiene goes a long way in enabling a process that will help you keep those metrics meaningful. Firstly, your dashboard should reflect the values and development priorities of the application you're monitoring. This sounds like an obvious and sort of generic principle, but I want to emphasize how important this was for us, particularly the more and more complicated our streaming application got. And with our simpler streaming applications, and of course with our non-streaming applications, we really just kind of loosely adhered to this philosophy, and it kind of just didn't really matter. But again, the more complicated you're getting, especially with these really powerful frameworks, the impact is just so much more significant. And we found that in order to really have our team be the best it could be, it was just so much more essential for a variety of reasons to have really good dashboard hygiene. So on this team, this was actually a real example of the top of our dashboard. And I also love this one as an example for one that's very well curated, having those metrics that are really the most important to engineers and that are really most driving that development process really right on top. So there are more metrics below. This is actually like a third of our dashboard, but we were super selective about what went onto this top part, although we're also flexible. So if the top engineering priorities changed, so did the dashboard, which usually meant swapping one chart out for another that was previously further down the list when it was time to focus on that feature, for instance. And this just kind of became a normal habit as part of our stand-up and roadmap work. For this particular Flink application, the consumption from our coffee topics and our watermarks, even just a sampling of them, were particularly valuable, at least at this point in the development of that application. Now, watermarks in Flink, and of course with other frameworks like Spark, as most of you probably know, but just in case, mechanism for controlling the duration of time from when the application will wait for a record to arrive. So this has many applications, as is also the basis for most event time operators. Watermarks often help determine how late records are handled, meaning this has a pretty big impact on whether, what order, and how data is ingested into the stream. So it's important, but it's also something that is usually an estimated guess designated by an engineer or team of engineers. So this is why it was super essential to us, especially in the really early development of the application, before we knew a lot about what our data flow is going to look like, what the software was going to look like, to keep a super close eye on those watermarks, because this was likely a configuration that we would need to adjust constantly as we got more information about the data coming through. Next, each of our incoming data streams had its own lag chart. So by taking some initial measurements of data flow and looking at the structure of the output, we're able to determine that some of our upstream teams aggregated and transformed their data very differently than what we expected and what we talked about actually, and that it actually differed by team. So having these metrics and keeping them at the top here, really understanding our normal, allowed us to ask better questions of those teams and really understand what those differences were. So how this helped drive our development process though, was that once these metrics were in place and we had that better understanding of just how differently data was handled between those upstream teams, it naturally guided a restructuring of ownership. This information was almost automatically redefined what responsibility we had for integration points in a way that we ended up having based on the behavior of the software itself, as opposed to what we had previously. So this was a much, much more efficient way of doing this. So throughput and checkpoint size were our next priority. Throughput is an obvious one. You want to have a good handle on how much data is going through your stream. We had our throughput separated out by which source the data originated from. This also enabled us to have an overall view of throughput through the whole system, and while also allowing us to click into each upstream application we needed. Really, the TLDR here is just having this all in one really quick space where you can see the overall as well as the individual. We found to be super helpful for a wide variety of different Flink applications. We also tracked our throughputs at each reduce function throughout the entire streaming application, which I also recommend. It would actually give us some very good data there. And then, as I mentioned, checkpoints in general for any streaming application, anything that's related to how state is stored for a stateful framework is just going to be so essential. So making sure the engineers are super clear with what's normal for that as well. And that brings us to our checkpoints. And this dashboard has a very unusual way of tracking checkpoints, which normally I would not actually recommend. And that brings us to keeping this process iterative. So it's much more common in Flink to track the number of checkpoints, usually for a certain duration like the last hour, or for any anomalies over a longer period of time like a day. However, for our team here, at this point in the application's development, we were under certain restrictions for how we wrote data to our syncs, and some syncs still needed to consume on a once daily cadence. So for this, we focus on the checkpoint size, which should follow a predictable pattern of steady growth with a single once daily drop. Again, very specific for this scenario. In this case, an abnormal drop or spike could mean that we were losing state, or in one case, that there's a mismatch in how incoming data from different sources were being timestamped. So overall, instead of being completely stuck on textbook metrics, which of course is a great place to start, it was much more effective for us to stay flexible. It was important to allow the data that we were receiving about our system, along with any other information that we had on our weird and unique situation, really trying to stay data informed here, to guide modifications to our metrics, even if it meant monitoring in very non-traditional ways. Okay, so you have a dashboard here that's meaningful, has prioritized metrics, and supports iteration and flexibility, right? All right, we got this prioritization, looks good, check. So, you also want to be really easy to use though. So especially if you're getting paid at 3 in the morning, you want to make sense of all these pretty lines and pretty colors. And especially if someone else is using your dashboard, especially if they're not familiar with Flink or not familiar with stream processing in general. So there's a lot of good techniques for this, but honestly, the most helpful thing I found is just keeping it simple and just thinking about scale. Because having the right things in the right order will definitely help with ease of use, but prioritizing a list of 1,000 items is still 1,000 items. So that brings us to accessibility and the actual practice part of metrics-driven development. There are a lot of resources about how to be intentional with what to measure and why and where you put it. A couple of my favorite quotes on this are one from the Harvard Business Review saying, "It is simple enough to describe how to inject data into a decision-making process. It is far harder to make this normal, even automatic for employees, a shift in mindset that presents a daunting challenge." Or more simply, a Tech Beacon article that reminded us that you can measure almost anything, but you cannot pay attention to everything, which I both love and hate because I just want to measure everything. I feel like I should have this like in a neon sign in front of my desk. But my favorite one though was actually from another engineer I was talking to earlier this summer who said, "Any situation where people create their own dashboards without structure quickly starts to look like the cockpit of a 747. Now, I know most of us haven't really been flying lately, but I still just really love this one because it's just such a great image of what an anti-pattern this is. And it seems so simple, but we've probably all seen a lot of dashboards that look like this at one job or another. So just a reminder to just nope out of that one. And with that, we can move on to our last section, which is metrics as a shared language. So another great Harvard Business Review article mentions that the biggest obstacle to creating data-based businesses is not technical, it's cultural. But more specifically, I like to think of this as even the best data-driven development fails easily when it's only built for yourself. So no matter how complicated, no matter how creative it is, if you're just building it for yourself, it's kind of happening in a void. So I think that's kind of where I think it's just so important to talk about some of these people issues with our technology. So this fact is something that on my last team, we could basically still ignore with a lot of our non-streaming applications and our less complicated streaming applications. But as I mentioned, with this, the integration points are just that much more complicated, and that relationship with upstream and downstream applications and teams, I just can't emphasize enough how important it is to keep focus on those integration points. So I like this diagram because, you know, when we first built our last system in my last company, we found that people from all over the company suddenly needed a lot more information. Explaining the same stream processing and Flink concepts, re-explaining our stream-specific alerts, and being included in incident resolutions that seemed kind of far from our domain, maybe, all suddenly became part of our development process. So some groups, like other engineering teams, needed the same granularity as us, but filtered differently. Other groups needed to be able to pivot between summary and depth, and still other groups needed full abstraction. And I like this diagram because it delineates the groups, but it also, kind of like our circle at the beginning, has the group in the center that needs the most technical coverage, and then you're able to see that those levels of abstraction growing as you go further out, as well as the way that you want to share them. So starting in the center here, monitoring for yourself. So this is probably the monitoring that we think about the most, and let's be honest, it might be the only monitoring we're thinking about, and maybe that's okay. So I'm not actually going to get too much into this because we've actually already covered a lot of this. This really was all about where to start specifically with Flink, with monitoring for stream processing, and as well as creating that practice of that meaningful, iterative, accessible metrics. So all of this really is about those philosophies that we spoke about and where to apply them to stream processing. But as we get further out, so we knew that on my last team, everyone that was looking at the same initial metrics, then no one would get the information that was useful to them, even other engineers. So there had to be some type of filtering or abstraction, but it didn't really need to be complicated. So in the end, most of this just revolved around a few additional basic data-driven concepts, including keeping our alerts in small modular units and using the language and tools of our intended audiences. In the end, this is a super simple solution of just relabeling alerts and our monitoring and just having a tag for the specific team it would impact, and using the Slack integration for PagerDuty, Jenkins, etc., routing only the alerts that pertained to a specific team to that Slack channel that only contained that team. So we did try things that were much more complicated and were way more fun to program, would be way more fun to demo here, but were way less fun to use, just not nearly as effective. So this ridiculously simple method scaled infinitely better than all those, and was able to keep up with any new complexity, which ended up being quite a bit, that both our upstream and our downstream ecosystems were able to throw at us with really minimal effort from us. So really, really keeping it simple just paid off so much on that. I do want to give an example about kind of this additional impact. So this is a slice from that earlier dashboard that we saw, showing the lag in data coming in from each of our upstream teams. So initially, we were alerting on any spike in lag over a certain threshold. This threshold had made sense to us. We used it in the context of our data pipeline. We based it on behavior that the majority of the other streams had that we were consuming. So it really seemed to make sense to us. We did genuinely put a lot of thought into it. However, although we did still clearly need this threshold, we have an abnormal spike at 9:45 in this example. The spike in lag from 9:10 to 9:15 was actually normal for these 3 incoming streams in this scenario. So this actually would have been abnormal for all of our other incoming streams. So we actually had more than twice as many as this. But because of how and when these particular ones publish our data to us, this also, I've seen this happen a couple other times with groups that have some incoming streams that are from other stream processing applications, and where they're also consuming from some batch applications as well. So this was their normal. And knowing this was super useful. So it really paid off to do that practice, to keep up with knowing what our normal was, which allowed us to streamline this and compensate for that in our alerting. However, there's also some downsides. So when working around a daily spike or drop that's nice and predictable like this, genuinely really awesome. It was so great to be able to know that and to compensate for it. but being aware of when those upstream teams decide to change their data collection or publishing schedule, especially if they are using batch processing, super important. But the worst scenario is that autonomous teams don't always have to use, to always base their event time processing in the same time zone. So you could have one team using UTC and one using, say, maybe a time zone that handles daylight savings totally differently, like PST. And you could very suddenly not be tracking or compensating for the right spikes and drops anymore. So even if you compensate for your daylight savings, that switch can, in theory, make quite a big difference. So at best, you're getting paid for something that's actually normal, but at worst, these nice custom metrics work against you. So overall, this is an example where enabling metrics to continuously guide how you measure and alert on your data, particularly around these integration points, is just so important, especially when you're combining streaming and batch applications. And this next level, I know this is starting to get a little bit boring because this is more abstracted. It's not the exciting part, but it is important, especially because I think there's some great ways of automating this, so you don't have to think about it as much. So leadership and internal stakeholders, they often need to be able to pivot between summaries and depth when it comes to metrics. And this may seem like it's not really your responsibility as an engineer, but as I said earlier, we were very surprised at just how suddenly and intensely we became involved in these areas when we were a streaming team in a non-streaming ecosystem of applications. This can be for other situations, but much more commonly for that situation. So if that's you, good luck with that. And I hope this is useful. So the best trick I found here is really, again, keeping it simple, just using the language and tools of the intended audience. As Noshnika Fee, a fellow developer advocate, said to me recently, the further you get from engineering, the more your status just needs a URL, but you be surprised at how far that gets you. So I've actually had a lot of success with that as well. For me personally, though, it was having a blog post with language catered to that audience, but embedding a few custom charts that automatically updated. So that was a great way to keep this automated, and the process of dealing with these various different groups and sharing those metrics in a way that really helped us not think about it too much, but still worked for all these groups. So this one I'm not going to get into too much here. It's also the most abstracted, because at most organizations, this is going to be outside of your general metric cycle, but we should probably still care about them. So I want to make sure that that's still an important part of that chart. So with that, we've covered using metrics to drive your development process for stream processing and Flink specifically by knowing your normal and why that's so important. So keeping those metrics meaningful, keeping them iterative, keeping them accessible. We've also covered using metrics to minimize some of the human challenges that come with stream processing. I know it's not always as exciting to talk about, but it's so important to be able to deal with those properly. So particularly because of that unique impact that we're going to have on the rest of the technical ecosystem. So specifically here, we talked about automating, filtering, and abstracting metrics in a way that works for these different groups for the people that share those integration points, keeping it simple with techniques like small modular units and using the tools of the intended audience. And with that, I am just starting to totally lose my voice. So this is perfect timing. Thank you all so much. Huge thanks to the Future Data team and specifically Tim Spann, especially for all the back and forth today with me trying to get this to work with from over here in the apocalypse. So thrilled to be here again. And thanks everyone that helped out. So I'm going to stop sharing here. All right.
Awesome. That was very cool. Is there, do you have any a GitHub with that or any additional links? You could use sign language.
Yes. Yeah.
Type it out.
Is that something that I can post in?
Yes.
Okay. I'll post it in the meetup after.
Rest your voice. We had to mute everyone because of some Zoom bombers, as everyone will remember. So if you have any questions, post them in the chat and we'll either get to you in the future or do a chat. Next up,
also,
Carolyn.
Tim, they could also raise the hand if they go to the participants.
Oh, okay.
You have the ability, you'll see at the bottom of where participants and chat is, they'd raise your hand and you'll actually come to the top of the participants list. We'll be able to then unmute you. So anyone that's co-host can unmute you so you could ask your question as well.
That's why John's here. He is the Meetup super guy. But if we don't have any questions, you can put them in chat at any time or at the end of the next talk or at the end or just in the Meetup group or on Twitter or on meetup.com or LinkedIn or, write it to a file
Perfect.
somewhere and leave the security open. We'll find it.
I just can't do any of the sky banners here. I won't be able to see it, but otherwise, any other way works.
Well, if it looks like my background, you might, right?
Right. Yeah.
Carolyn, are you ready? Or you want a little time?
Nope, I'm ready. Can you guys hear me okay?
Yeah.
Okay. Well, let's get on with the show here. Thanks, Caito. It turns out that what Caito was talking about is gonna mesh well with my presentation. So I promise that we didn't really coordinate that much, but it turns out what we're doing is pretty related. So, all right, let me get on the right slide here. Maybe not. Okay.
Not sure if you want to be on video, Carolyn, but you're not. So
I'm not on video.
Yeah.
How's that?
There you go. Perfect.
That better?
Always. Yep.
All right. Let me see if I can get Zoom to present the right thing here. In which case, and that is not what I wanted. There we go. Do we see it now? Streaming in the real world?
Yep. Looks good.
All right. So, thank you for inviting me tonight to your Flinky Fest here. I am Carolyn Duby. I am a principal solutions engineer at Cloudera. My specialty is cybersecurity, but I also do general cybersecurity and other types of use cases as well. My goal at Cloudera is to help make my customers as successful as they can be by identifying use cases, recommending solutions, and pretty much doing anything to make my customers happy and successful. I am the lead cybersecurity subject matter expert. I have a background in engineering. I supported a production grade cybersecurity event correlation at a managed security services provider. So that's basically the 25 words or less explanation is we take events from cybersecurity appliances from customers, and they would bring them into the data center and then figure out if something bad happened. And if something bad happened, they'd help the customer fix it. So that's kind of like the very simple explanation of what an MSSP is. It's a lot more complicated than that, but in general, that's what we did. I have a bachelor's and a master's from Brown University, and I had to learn some other things since I left school because new things come up, and went to Johns Hopkins, did a online Coursera specialization in data science. My Twitter handle and my LinkedIn are there if you want to connect. Would love to hear from you. And if you have any questions, feel free to follow up with me later, or ask questions in the chat. And maybe Tim or John will tell me what's going on. So anyways, I'm going to talk about streaming in the real world and some of the perils of supporting a streaming application in production. So what I'm going to talk about today has to do with cybersecurity and what happens in the cybersecurity event pipeline, but a lot of things are similar with other types of streaming applications, right? So typically in cybersecurity with event correlation, what you'll do is you'll take a whole bunch of log text items that are in a million different formats, and then you have to determine, is this something that's an alert or not? And sometimes it's simply you just look at the thing and it's actually it tells you whether or not it's an alert. And other times it's more subtle, where you kind of have to look at that thing and correlate it with other things. You have to add some data to it. You have to do some machine learning. You have to do some other types of triaging. But basically, you know, the majority of the events that you're going to get in are going to just be benign events, and you're just going to store them out in an event data warehouse. But a small percentage of them are going to be malicious, and then you'll have to do something with them. All the events are going to go into the event data warehouse, and from there, we can do other things like visualizations. We can make nice dashboards from the data. We can do detection, you know, fraud detection and user behavior analytics, threat hunting, and then responses and investigations. So that's at a high level what the streaming pipeline is going to do. But again, this is very similar to what pretty much every streaming application does. Is it gets a bunch of data, it takes the data and maybe enriches it or correlates it or comes up with some sort of actionable insights about that data, and it's usually put up on a dashboard, or there's some other type of escalation or alerting that comes along with it. So a lot of what I'm going to say is going to apply to other things as well. So just to kind of talk a little bit about what happens in the pipeline, there's lots of different formats. We have to create a common schema. Again, this is typical of a lot of different things that come in, right? You're going to have a lot of different alerts that are going to be coming in, or data. If you have IoT data, or if you have, you know, healthcare claims or anything that's coming in, you're going to have different schemas and different kinds of data that are going to come in. You're going to have to rehydrate it and then prepare it to be stored and to figure out how to triage it. You know, so for enrichment in cybersecurity, we bring the data in. We're going to be adding things like geocoding, like where does an IP come from? We might add some information about assets that we see inside of that event. So is this a really important database server, or is it just a random, you know, laptop somewhere? What is the users? Where does the user work? What department are they in? That sort of thing. For detecting alerts, there's lots of different things that we can do to detect alerts. We can apply threat intelligence, which is basically known bad, malicious IPs, domains, URLs, file hashes. We can have rules that report on known bad events. So when we see this particular field in this particular combination, that's a bad event. And then there's also statistical and machine learning to do anomaly detection. So this is a big focus of what we do in the real-time pipeline, and then also after the real-time pipeline, looking at events at a longer time frame. So, you know, how did this particular entity act over the last year? And then finally, the fine line that we have to walk is minimizing false positives, right? So we don't want to give the analysts too much work to look at, because there's only so much they can do, and there's only so many analysts that you have. But you don't want to let hackers kind of walk away with data, you know, make backdoors into your system, install malware, right? So you have to walk a very fine line. And that's where we come in with the scoring. So I'm not going to go too much into this. We have model as a service, you know, we incorporate models into the streaming pipeline. The architecture for a streaming and ingest pipeline for cybersecurity looks sort of like this. We're going to be getting raw logs. They might come in through NiFi. We drop them into Kafka. We pick them up with Flink. And then we're going to, at that point, once they're completely and fully enriched and triaged, we're going to put them into the data warehouse. And then from there, we can have in the data warehouse, we can have all the applications that we want to. We can train machine learning models using Spark. So we can do that. Okay, so this part of the talk is I've titled "When Bad Things Happen to Good Systems." So, you know, Caito went over, in great detail, different types of metrics that you might want to look at in your streaming applications. This is a talk about some of the bad things that can happen in your streaming application. So if you think about a streaming application, there is a lot of data coming in. So for example, for cybersecurity, if you look at a large enterprise, they're getting between 1 and 10 terabytes of data a day. So that's some of our really big cyber customers are getting millions of events per second. So that is a lot of data. And if something goes wrong, the data will kind of pile up in the system. So let's talk a little bit about some of the things that we have to look at. Hardware failures. So when you're taking in 10 terabytes of data a day, you have a lot of hardware. And when you're storing 10 terabytes of data a day, you also have a lot of hardware in your data warehouse. So big data means lots of hardware, and hardware tends to fail. And so in almost all of the systems that we work with in these horizontally scalable platforms, there's redundancy that needs to be built in. So for example, if you have data, it needs to be replicated 3 times. That's in both HDFS, when you store the data in your Kafka topics, especially, you need to have your data replicated 3 times because servers are going to die, disks are going to die, things will just go bad, and you need to have that redundancy in order to not lose data. All of your critical servers need to have active, passive, standby, and you need to be configured for HA. And this is not just for dealing with failures, but it's also dealing with being able to update and restart the system, right? So if you don't have HA, your system is going to basically stop when you need to reboot something. So if you have to patch the OS, or if you have to do some maintenance on the server, that's gonna cause an outage. So you'll find in a streaming system, for the most part, the system has kind of a natural ebb and flow of data. So for example, when I supported our MSSP ingest pipeline, this goes for probably most of the enterprises out there, the data is going to kind of have this natural daily ebb and flow. So at 10 o'clock in the morning, maybe the data starts to pick up. You get a lot more events because people are coming into work. I don't know, maybe things have changed since COVID, but a lot of people are coming into work, they're coming online, a lot more events are happening. And then around 6 o'clock, things tend to slow down a little bit. So this is kind of like a natural ebb and flow of the data. And for the most part, you're going to get certain levels of data at certain times of the day, and that will be most of the time. However, sometimes things happen. So, you'll either get an incident or you'll get just, the typical thing that would happen is folks would set off their scanners and they'd start scanning things, and then that would cause all of their security devices to kind of go haywire because they're like, hey, somebody's trying to scan us. And they're like, yep, it's supposed to scan you, but it's it's a known scanner. So, there will just be anomalies that will happen throughout from time to time, and you'll end up with a big peak of data, or something gets misconfigured and it starts sending a lot of events that it shouldn't send. So, you need to be able to build in elasticity in your system. So if you're deploying inside the data center, you need to deploy extra capacity for when these things happen. Or if you're deploying to the cloud, you need to build in elasticity through something like Kubernetes or something like that. So you always need to have extra Kafka capacity, and you never want to run out of disk space. Running out of disk space is the worst thing in Kafka. So you need to monitor for it. You need to, if you start to get more full, don't wait till it's 99% full. I learned that one the hard way. Wait to, give yourself a little room and time to to react to a disk getting full, so that you can start either adding more capacity or bringing servers online, or by cutting down your retention rate. So, for example, typically, Kafka brokers, you'll retain data for at least a day in case something bad happens. But you can cut down on that retention if you start to run out of disk space. So build in extra capacity. Make sure you're monitoring for your disk space. You're not running out of disk space on your brokers. And then monitor your latency. So the slower, if you have something that's producing a lot of data, but the consumers are consuming it slowly, that's what we call back pressure. And that's back pressure. Sometimes it will just resolve itself. So, the incoming traffic will kind of cool off a little bit, and then your systems will have some time to work through the backlog. But if your system continues to be backlogged, then you're just going to kind of build up, and you're going to start running out of capacity in your Kafka brokers. So the other half of capacity is the storage, right? So every time you're getting in an event, you're also storing an event. So if you start to get a lot of these spikes, or if your ingest changes, so, when COVID happened, a lot of people started to work at home. And so there were changes in the way that the networking worked, and the firewalls worked, the VPNs worked. And so everything is changing as a result of that. And so, things will happen, and you'll have to adjust in a very elastic way. And you'll have to monitor your storage growth rates. And again, either adding more capacity or cutting down on your retention rates if you can do it. So when you're architecting an event-driven system, you want basically each event to take a predictable amount of time. You don't want an event processing to take some events to take a really long time, and some events to just go by quickly. You want to kind of average that out and have a predictable amount of time that it takes to process each event. So this means, really optimizing what you're doing in the streaming ingest pipeline, making sure that, you're not calling a lot of web service calls. You have to do caching. You have to use some very smart caching instead of going off to do web calls or making external calls to different services. You want to be able to make use of caching to reduce that, and then reduce as much as possible those, so instead of just going off and, so for example, one of the things we do with domains is we will check the threat intelligence that's stored in HBase, right? So if we know that we just checked that domain name and we just got back nothing, then we need to keep track of that and use a cache so that we're not constantly going back to HBase to ask about the same domain. But sometimes things will happen, the system will get slow. So you have to look for those patterns of slow events. So you'll start to see the back pressure, you'll start to see the backlogs build up in your system. And then you need to have some monitoring in there to figure out, how come these events are going slow? So one of the things that we did in Netron was we actually put timestamps. So we put timestamps of when we got the event in, and then timestamps of when we got the event out of the full pipeline, and at each stage, so that you could tell which events were slow and how long it was taking for the events to be processed. I think that's it for that one. So a lot of times when you're ingesting data, especially in the cyber realm, you know, things will happen, devices will get upgraded, and a lot of times, you know, we don't know that they're getting upgraded, or you'll get an event. You know, there's lots of different formats of lots of different types of events that you'll get from a device. You'll get one that you just don't recognize. Like, I've never seen that event before. So you don't want an unexpected event to gum up your pipeline. So the natural tendency is, I've got an error, I'm going to put it back through the system. Well, that's going to work if the error is a transient error, but if it's an error in the data that's causing the system to act improperly, that event is never going to process correctly, and it's just going to keep going back and back through the system. So you need to look at each one of your errors and figure out, is this something that I can fix? Is this something that I can recover from? Or is it something that's just a logic error? And then those things that are logic errors or data errors, you need to quarantine them, and you need to check for the quarantine to see if you have events that have been failing. And you need to monitor for those, and then you need to look at your failed events and figure out what happened to them, and then fix the errors, because you don't want to lose any data. So this goes for pretty much any streaming pipeline and any sorts of alerts or responses that you're getting from the pipeline. But you again have to walk a fine line. When you're doing your detections, you don't want to have so many detections that you're overwhelming whoever's looking at those detections. But you don't want to have too few detections so that you're actually missing alerts, and then bad things are happening, but you don't know. So you need to constantly monitor the system. And this goes with pretty much any streaming ingest that's using anything to do with machine learning or automated detection, anomaly detection. You need to monitor those detections, and you need to tune them to see, you know, is everything coming out okay, or is everything coming out as an error, or am I having a lot more errors than I normally did, or a lot fewer errors than I normally did? So you need to keep careful track of that, and you need to understand whether or not, you know, when you need to look at the system to make sure that it's working properly. So I'll talk about disasters. With any business critical function. So cyber is a business critical function. If your cybersecurity team is not functioning, your system is you know, out there for hackers. So you need to build what's called a business continuity plan. And this is the same thing that you would do for any streaming or any other type of application, data application that is business critical. So, you know, you need to have multiple data centers, and you need to have duplicate copies of the same data running through both data centers. And they need to be both running the same software. So in Kafka, there's the new Mirror Maker 2, which is really awesome for this. And you know, you need to basically, a lot of companies, they're like, yeah, we should have DR, but then I have to go buy all those servers. But they're not really thinking about what will happen if your servers are, you know, in Florida when the hurricane hits and they're out of power for, you know, 7 days, right? So this is happening, or an earthquake happens, or there's just some general there's just some general outage, for example, of your network, right? So you need to have business continuity. And then it's also helpful, for example, when you want to upgrade your servers and install new versions of software, being able to run out of your secondary data center and upgrade your primary data center without having any outages. So this is also very, very useful. So I think that's it for me. I think it was enough talk of bad things for tonight. Did anybody have any questions in the chat? Let me go over to the chat. I don't see any questions.
Yeah, maybe
Everyone
they
was like,
can
that
ask them
was
later.
depressing.
It's too complex. What's cybersecurity?
What's cybersecurity? What's a log event?
What's a log? It's a little easier in person, though. Even there, we don't always get too many questions.
All right.
Everyone put their questions in a Kafka topic and we'll consume them at a later time. That'd be kind of cool.
It'd be really cool.
So I
well,
guess
I'll have to say I would have liked to have Caitlin's Caito's dashboards. Those are some like darn nice
like
looking
those.
dashboards, I'll have to say.
Yeah, mine are sad.
Yeah, we just had like really sad looking Grafana ones. So
I love
All
thinking
right.
about dashboards.
I think we're on to who's on next.
Who's on
Ian?
first? Actually, I have a little talk if Ian's not in yet. Mine is just some random junk.
Yeah, I don't
But
see
it's the,
Ian.
it's the flank part. And someone did ask about NiFi. So as
All
per
right.
my contract, I must inject NiFi into every conversation.
All
It's
right.
$1 a word.
All right, I'm gonna hand off my depressing talk to Tim, who I'm sure will have something more fun.
Uh-oh. Now there's pressure here. Yeah, mine isn't much as of a talk as look at some stuff. And it's not too exciting, but I have a couple filler things around flank. Since I did put that flank in there, it's not just in there to make it flank, flunk. We're gonna avoid the flunk part. So we're gonna do a little flank here, which is my term for flink plus NiFi plus Kafka. It's sort of to me, those are the super friends. They work really well together. And I'll just show you a simple app. First, I want to show you my very sad, this is my UI for monitoring. I think that looks fine. I don't see why there's any problems with that. Clearly, if you look at that, you can tell what's going on. See, this state here is canceled. So my thought is I'll read the Flink REST API and produce a horrible graph that's of no help to anyone. But maybe I can programmatically look at the REST points and do something. Because I don't have a nice dashboard, but maybe proactively I can look at that. We do use those calls in our very bland dashboard here, but it is kind of helpful. I'm really loving Flink SQL because then I don't have to write a very complex Java app and have to press deploy. So that's kind of nice. One thing I just learned about, which is pretty sad, I just learned about it, is the different catalogs that you could connect with Flink SQL. So I've got a couple here. These are kind of cool. If I use, say, the Kudu one, and I look at the tables here, I can see all the tables I have in Kudu, and I can query the Kudu tables. That's kind of cool. But I have a more interesting one for me is the registry. This is the Cloudera registry. Obviously, a command line interface today is very exciting. And it works with my dashboard too. But I just like this instead of having to deploy a full Java app to do something, just to be able to query some data real time. And where does this data come from? This registry. I'll show you where the registry is, but I want to just describe one of these tables to give you an idea. If you didn't know, this is showing all the Kafka information because this is a Kafka topic. And this is the all the fields. And the reason why it knows what those fields are is because they come from a registry that's connected to Flink. And it's also connected to NiFi and also connected to Kafka. So sort of those flank friends. That's this schema here. And I could change it, make it a better schema. I made it so I can evolve this and add versions. But I just have the fields that I'm going to use. Because I have this schema, I can now write queries against my Kafka topics. This is a full distributed app running by me typing one SQL select. I didn't have to create any tables. Here's that query here. This is a little better interface. I'd rather run the query here, but we'll see what happens in the future. But that's all I needed to do to grab a table that's not a table and do a live query in it. That's pretty neat to me because I didn't have to define anything. I have this one schema for that data that I can use, as you saw here, in Flink, easily running a query. I also use that same interface to be able to deploy an app. And this app is this very complex app right here where I'm inserting into another table, which is a Kafka topic from a different Kafka topic, this item price one we looked at, just based on some value. That's really nice way to just get your data really simply. And because it's a schema that I have in a registry, anyone else can use it. So when I push that data from, say, NiFi into Kafka, this is how I'm pushing to that. I'm just pushing it to the same Kafka broker, that topic. I'm reading, I have JSON input coming in from a REST endpoint, very simple. The one thing I'm doing that's a little, makes it easier for me to digest that data, I convert it into Avro and make sure I reference the schema information. So everyone knows what this item price data is. So I can look at the individual topic in Kafka and see, okay, this is the data, Avro. Okay, let me turn it to Avro. Using that schema, now I know what bananas I have. Very important if you like bananas. So the data is coming in and I can see what it is within Kafka, even though it's Avro because it has that schema. And I can see what it is in NiFi. I pushed it into NiFi here as I converted it. And then I'm going to consume it within NiFi as well. So I can push that, consume that Avro data. I could left it Avro, but I convert it to JSON. Why not? And then I push it to a table. So I could just have that in a permanent data store. Let me go to the right table. Fortunately, Kudu's pretty fast, so I get my data back. So I'm just pushing in that data that's coming in, get ordered by date. Should have these queries pre-populated, but I'm too lazy here. So the data is coming in. We see as it's coming in real time. Very easy for me to share that schema in NiFi part of Flink. I'm using that as part of my query and my insert statement. So that's, let me go into the last row. As data is coming in, it's showing up here, one event at a time. So if you wanted to write an app, it's very easy to extend the SQL to turn that into an app that does cybersecurity or any of the 10,000 apps you could do in Flink. Very straightforward. What's nice is it's just running here. As you see, I stopped that query. So all I have is that insert running. So as records come into item price, if they're from meet that criteria, they'll get pushed into that other topic. Another thing I'm doing is I have a Kafka Connect app that's also using that schema to read from that topic and push those Avro messages to HDFS. So now I've got NiFi using one scheme, I know what the data is, Kafka using that within its metrics and monitoring, and also Kafka using it in a Kafka Connect app, plus Flink using that schema so I can do queries, and not just queries, because I have all these ones. I can do inserts between them. I could do joins. There's some pretty advanced SQL you could do. And what's cool about this is event at a time. So if you want to do any of the fancy features of Flink, like do it over a period of time, you could do some really cool things with aggregates. You know, it's really up to your imagination. Also, there's some built-in functions you could use. I'm using one to generate a unique ID to add into my other topic. And you could also write user-defined functions. And I think Ian Brooks has one. So if he shows up, maybe he'll mention that. But it's a pretty good way to extend that SQL, make it even more powerful. So we're using that data, pushing it into a couple of places. Very straightforward. I'm doing the same sort of thing with weather. I haven't written the Flink piece for this one yet, but it's the same idea. Whatever the data is, you know, I just add a schema which I can have NiFi derive. Ian is here, so I don't have to show my boring demo too much longer. Hopefully his environment's working. I think it is. And then finally, when I'm done, I can just push that into a graph. Like for the weather data that happens to have Latin long, so I can grab that data and put it in a graph. What we have coming is visual apps that'll read from Flink SQL and read from Druid, which we could populate from those Kafka topics. So I guess I'm going to have to make it deflink or flinked. I don't know if I add Druid to the mix. Right now, I have the K is for Kafka and Kudu. I don't know where I put the D. Is it flanked? Is it deflank? I'll have people vote on that. If I want to put Druid in there for some other real-time visualizations, but we'll see. For now, just being able to push that data into Kudu and have some nice little reports that look a little better than this is nice. Probably no questions on mine since it's just a little demo, but I wanted to make sure Ian had enough time. Oh, this is a good question, and we have a good set of people on here that can answer that. What's the difference between Flink SQL and KSQL? Now, number one is Flink SQL is Apache and it's open source. The thing you might not realize with KSQL is it's not open source. It's Confluent only. So the other people in the community who support Kafka, which is a bunch of us, can't use that. The other difference is Flink SQL is not just Kafka. When you do KSQL, you're querying Kafka. As we showed here with my catalogs, and Caito can show you a whole lot of other SQL things you can connect to. So you probably write a whole list, or we'll point to the apache-flink site or Riverica's. Like for me, I can connect to Kudu. I can't connect to Kudu tables in KSQL, and probably wouldn't want to. Also, the SQL dialect within Flink SQL is very rich and doesn't have any weird proprietary pseudo SQL parts there. Also, Flink scales pretty insanely. I mean, you've got, I don't even know how many thousands upon thousands node clusters out there for some of the largest organizations in the world doing some really serious work there. I don't know that that's the same for KSQL. And again, as someone who's speaking at ApacheCon in a couple of weeks, the fact that it's open source and that there's multiple vendors supporting it, and just the performance I've seen and just the ease of use to join things together, just to connect them as part of, like I said, part of the Flink stack. There's a lot of nice features with Flink SQL. I don't know if Caito can talk or just type if she wants to put an answer in there, or we could put a link in later. doesn't matter. Like I said, Flink SQL is pretty awesome and open source. I see Ian is on video. Oh yeah, that article is pretty awesome, where they show the different examples, but what people use Flink SQL for and what they use KSQL for. And there's a lot of similar reasons why you might want to stick with the open source and things like Flink SQL, which go beyond just Kafka, even though Kafka is awesome, and it kind of messes up my Flink stack if I don't have Kafka. But there's also Pulsar and other options, MQTT, other stuff. Ian, you're becoming invisible.
He's a ghost,
Are you
man.
ready
That's
to
what
share?
happens when you stay in that hotel.
Yeah, that's not the safest place to be, man. It's
That is
getting close to
exactly what
Halloween.
happens.
We are going to have a Halloween theme one, though I do have some talks elsewhere around there, but maybe middle of October we do a Halloween theme one.
Nice. All right. I'm having some real issues with my camera. So
Hey, if you
I
want
know
to
there's an ugly
that's
ugly star on your shirt, man.
I can't seem to get it off. Like it doesn't seem to rub off. So, what are you going to do,
Starting Sunday, we become enemies again, no longer friendly.
Oh, there it is. Look at that screen now. All right. Well, Tim, I'm ready to go, man. Whenever.
Okay, fire it up.
Okay.
You should have permissions. Hopefully.
Trying to get all this situated where it's not crazy here. Okay. I've been having permission issues with Zoom, so.
Oh,
Did you just
yeah, I
upgrade?
made you co-host. You should be okay.
Yeah.
If you just upgraded your MacBook, then that's probably
Yeah.
what the problem is. You might have
Exactly
to
what
sign out and sign back in.
Okay, let's try this.
So you accept it.
Can you all see that?
Yep.
Awesome. Okay. Oh, well, that's great. Okay. So yeah, I mean, it sounds like Tim has been really drilling in onto the concept of Flink and Kafka. So I really won't spend too much time on that, like just talking like that today. But I like to look at these two Apache projects as two tools that really work well together. So quick introduction, myself. I was a Horton worker. I'm now with Cloudera. I've been working with big data since 2015. I got a PhD a few years ago from the University of North Texas, and I'm having a lot of fun working with many of the folks on the meetup today at Cloudera. I mean, why am I excited about Flink? Obviously, I think everyone's pretty excited about it. I just think that the capability to be managing trillions of events is really pretty incredible. It's a really incredible tool. And there's a lot of great things about that. So we could drill on all day that, but obviously I'm a big fan of Flink, and you'll see that today, obviously. So what we're going to look at today, let's just get to the fast forward here. Some folks on the call may have seen my last meetup with this. I've actually added a little ML spice to this actually. So what we're going to be doing today is using apache-nifi to ingest a CSV file and just do some light transformation from CSV to JSON, push that into a Kafka topic, and then use apache-flink for all the real magic here in the case. So today, really focusing on the highlighted purple part of that, which is AI machine learning serving. I'm using a model that came from H2O, and it's pretty interesting. It's actually a self-contained model referred to as the Mojo. And what this actually can do is I can, with Flink and this model, I can do real-time scoring, essentially like in real time. So I can do machine learning scoring in real time. So inference in a sub 50 millisecond kind of like threshold. Pretty incredible what you can do. And that's what I'll actually show you today, everything else. And I've the whole demo actually writes back to Kafka, and I have some other pieces with this. I actually do have a Druid piece of that. If folks on the call want to see that, we can talk about that later on here. So let's just jump straight in to kind of the first pieces here. I'll show you the NiFi flow so you can see. I'm not hiding anything from you. I have this out there on a repo itself. So this is just the simple processor that's actually picking up the CSV file. I'll show you where it is, just sitting out there, and it will do some simple splitting, push it out to Kafka, and I have that sitting right here in a queue right here. And what I'm going to be doing is just writing out a JSON New York, or like taxi cab record from New York City. It's going to have some just very simple information, and I'll show you that to you, and then I'll show you it too in Flink once it's actually ingested it. And if there are any questions, just please just start throwing at me. I know we can have a little fun with this. This whole setup here. Okay. So just pretty simple, like one record itself, one transaction. Just notice the medallion ID is kind of the universal identifier of the taxi cab driver. There's some pickup times in here as well. What we'll actually be trying to predict is the actual charge of the fare, presumably when you would be getting picked up, right? So the model I'll be using today, it was all built with driverless AI. I was working with some of the folks at H2O, just trying out some of the software for everything else. But I just thought this was a interesting way to play around this. We can always improve the model today. I can't sit here and pretend like the model performed greatly, but it didn't send a lot of data at it either way. But just notice that we're going to try to predict this value in the air. I just want to show you what that looks like there. Okay. Zoom video is getting in the way there. Okay, so we're going to step over to the Flink application, and I'll start kind of talking about this a little bit pieces here. This is what I actually like to use for Flink. I like to run it in IntelliJ. Itself is a great way to actually manage Flink. Itself is running, and it's listening on the topic we're going to write to back in the NiFi side. And you can see I've got some of the other data itself here. What it's going to do is ingest this JSON, and itself is going to actually do the prediction, which is this row right here. So you're going to see the value of the fare, and this is the predicted fare. And when I actually just turn all this on, it'll start flowing out in data here. And you can see that we're doing prediction in real time. And I'll step this back as we go here. So just turn it on real quickly. And just so quickly right there. So right there, and then so it's ingesting what are, like just pretend like new records, and as it's running through, it's reading them, and it's just giving you a prediction score right there. So there's the medallion ID, what the fare would have been, the predicted fare right there. So that is actual machine learning in real time, which is pretty exciting. And this is the big piece of that, of course, is leveraging what H2O brings with the Mojo, which is these self-isolated machine learning models that are just effectively Java jars. So they're pipeline in the sense that you do all your transformation steps. You pass it raw data, and the transformation steps are built into them. And so when they do inference, they're prepared to do that. So what I'm saying is the steps that you do to prepare the data for training of that model, you encapsulate in that model. It's really cool. And you can see right here, it's just going to run out. It's just going to keep scoring as we go along there. So so we'll go back to the architecture here. Just kind of let this keep going here. So that was pretty quickly. Are there any questions on that? I just wanted to throw it out there. If you've all been talking about Flink all day, there's no need to talk about Flink for 10 minutes to set this conversation up.
So we do have everyone muted, Ian. So for those that want to ask a question, you can raise your hand. We can unmute you. Or Tim, it's probably safe now. We could probably unmute all. You want me to do that? Or at least give the people the ability to unmute themselves?
Yeah, give it a try. Let's see what happens. I'll keep my
I mean,
finger on the
yeah.
trigger here.
So we're allowing people to unmute yourself. You should now have the capability to do that. So if you have a question for Ian, now's a good time to ask. Ian, they're just shocked, man.
Well,
I'll be
I
ghost.
think
I'll just turn into a ghost.
I think the next thing you need to do Ghostman, is look at the new DJL. I posted it in the chat before. The new DJL framework for Java has a very interesting Flink example that does deep learning sentiment analysis. So that might be another framework to play with.
Yeah.
It's kind of cool.
Yep. Okay. I've got a wall, like a Sharpie wall or a dry erase wall over here. So
If there's a little, if there's two kids behind you, should I tell you?
they just want to play. They just want to play. Okay.
Yeah, they Zoom bombed me before, so you never know.
Don't worry. After we get done with this meetup, I'm going down to the bar. Don't worry.
Yeah. By the way, like, you don't just have to ask him questions regarding Flink. So if you do have a question of general machine learning, data science, any of that stuff, Dr. Brooks here is really good with that stuff. I mean, he's my go-to data scientist here when I need someone to build something or I have questions about things. So out of a company of 3,000 people, I go to him. So if you have any questions just about general data science, model building, any of that stuff, it's not a bad time to ask.
Yeah, fire away, and I've got some Druid.
The doctor is in.
Yes.
I have some Druid running right here. We could talk about Druid too. It's a little bit different conversation.
Yeah, show a little Druid, man. That's different.
Okay. Yeah. Okay. So yeah, I mean, Druid's really great if you want to do queries on that streaming data and effectively treat that that Kafka topic as a SQL table in the sense here. So you have to start from just loading data itself. I mean, Kafka itself, I found to lend itself pretty well to this. You know, there's HDFS, there's some other examples out there. So when you step through and actually collect this, so I'll have to kludge through this because I don't have all the IP addresses off to my head here, but we're actually looking for, in this case, what will be that Kafka topic. Let's see, give me a second. Let me dig through this, one of these files. Okay, this is a little boring, but kind of what you end up doing is it loads data in kind of these chunks, which is what you kind of see here, these segments of data. So you can set those segments of time that it kind of feeds through that, and it will do some the OLAP style query that you like. So when you're actually querying it in, you can roll up on specific fields. So one thing, good example for that is kind of here, right? This is that medallion ID, and I'm sort of repeating those numbers a bunch of times. You can see that I'm actually just counting that out. Another good example is this itself was a territory number of value in New York City that it's been summed 40 times, for example. So it's in a way to demonstrate some of the things you would do with Druid over streaming data itself. And then the cool thing, of course, is plugging really something like supersets into Druid, giving yourself a real-time dashboard. I think that's the most powerful piece of that is Druid will be that engine to manage streaming data coming in itself, though. So and once you get it working here, it does take a little bit of time, but it is pretty cool. And then you can do, you know, all sorts of little queries based on that. It just acts like a table at that point, which is really cool. Which is similar to what you're doing in Flink. It's a little bit different though. You're not doing anything OLAP effectively. Where Flink itself can query Kafka and treat it like a table, tabular data, and that's just SQL queries. It's the way that you're approaching that's a little bit different. So that's just something I'll throw out there with Druid. I'm you know, that's the nickel and dime Druid tour, y'all.
So obviously, Superset and Druid's a really good way to develop dashboards. Have you gone that far yet? I know, with new tools coming out, Superset might not be the best bet, but if you want to just see the capability to look at things, have you messed around with putting Superset on top yet or no?
I haven't. I've tried Superset a couple of years ago with Hive. It was okay. They've both come a long way. I kind of went back with the ML direction with this project. So, it's something I could probably do. It's something I just, we have so many projects to do, you know what I mean? So it just kind of depends on like where you want to spend your time. So it would be cool. It would be cool to add to this. It's just something I just haven't done yet. And I got Tim over here cracking the whip on me sometimes. So.
Yeah, we got some other event. We got ApacheCon coming up and NetHope.
NetHope, yeah. I knew about NetHope. The other events I didn't know about until they show up on my calendars.
Well, ApacheCon, you better get ready for, man. That's in like 2 weeks.
Yeah, we'll have to prepare for that. What are we doing exactly?
What are you laughing about, John? You got one too.
Dude, I can do incremental pulls out of a database with no problem. NiFi, it's like I've got like 50 different templates.
That should take you about 11 seconds.
Yeah. I've got one for Postgres, one for MySQL. Hell, I even have one for SAP if we can get an SAP database up and running.
There's probably a Docker for it somewhere, but it's all in German.
Yeah. My German's not good.
So you can even see right there as we've been talking, it's how quickly. Let's see.
That's pretty cool.
How quickly the NiFi,
so many interfaces to Kafka, man, for doing SQL. Whether it's Druid, Flink, Hive. Very nice.
It's pretty awesome. Can we go back to the Mojo? Like, so can we look at how? So
yeah.
Obviously we're not trying. We don't have anyone from H2O AI to talk about how they build their models. But what separates this from like saying building and training your own model, then deploying it instead of being able to use the pre-built Mojos? I know you kind of briefly touched on it.
So you got to keep in mind here, it's not using a pre-built model. I built a model that has this thing they call, it's proprietary, a Mojo API. So I have this class called Austin Powers. We got the Mojo here, having a little fun, of course. And I'll show you kind of what it looks like in some Java code. Effectively, think of this model at this point as a Java jar, right? And all I'm doing is I'm loading, let's see. Yeah, sorry guys, I can look this code in 2 days. I'm passing it a path, and then I'm just loading this model. Okay. This thing now just acts like it's just a Java class, right? And so if you've ever used mleap, which is a way to do inference with Spark models without having a Docker, having all of the Spark libraries, this is really similar. You effectively build, they call it a frame, but mleap calls it, there's kind of similar terms for it, but you're building row by row here, setting the values, like this is a test, for example, and then you're just passing that value, and then you're taking the response, and I'm just writing that out effectively, right? So it's nothing more, it looks to a Java programmer, this looks nothing more than a Java class. That's what's really cool about it. So why that differentiates itself is that I don't have an open today. I don't really, other than mleap, I guess it's the only one with Spark models. I don't have a lot of ways to have models that I have trained using scikit-learn or TensorFlow that are self-isolated, as in they're just Java. They're just like a Java class now in this case, right? That's really cool, and that's what makes this really, really fly, right? When Flink, I think the first iteration of Flink, they were trying to do something in this vein, but it would be on more native to Flink itself. The current iteration of Flink, they don't have much in what they refer to as Flink ML. It's out there, and I've kind of looked at it, but it's really kind of deprecated at this point. I don't know if Flink just decided to get away from that, decide to be, an event processing engine and themselves not worried about the ML side. I'm not entirely sure, but so that's kind of the approach we're here at now. In the future, if I could find a way to do this using open source tools, and it didn't have to be MLeap specifically, which is a Databricks run project, that's where this could come into play. You could use this a lot of ways though. But what is cool though, using the tools that they have, you basically hand it the data and it will train this model for you. But you kind of can tune that and kind of view that out. So that's something the H2O guys can talk about in some more detail. I don't want to steal the thunder at this point.
Yeah, no, that's pretty awesome, man. It's pretty fast. Like it's giving you return values relatively quick.
I mean, as soon as, and honestly, I'm just capping it with, the only reason it's not going faster is on the NiFi flow. You're
choking
I'm just
it, right?
I'm just clocking it. Yeah, I'm just clocking it right here, right? If I open this thing up, it'll just keep
Go to
going.
scheduling. Yeah, under scheduling. What do you have? Like every few seconds, 40 seconds. So
I'm just clocking this thing down. We could turn that thing up, and then the Druid queries themselves will go as fast as the data will come in. It's just a matter of those things. So it's pretty cool. Actually, it is the whole combination of these things is really cool. What you can just do with open source, and I'm running all of this on Docker containers right now. There's no special on my laptop, right? There's nothing special going on here. It's really pretty cool.
Yeah, it's pretty neat. Anyone else have any questions? Is anyone still there?
Everyone fell asleep.
Anybody out there? Well, I finished them off. I just put them to sleep,
We just get more and more obscure as we go along. Do we have any project that's been around for 7 or 8 minutes that we could talk about?
No one left though, Ian. So don't. I wouldn't feel bad. They just might be quiet people.
Or the mute stuck.
So
is it?
Yeah,
I can unmute all if you want.
Have you guys looked at that from the Flink perspective about how extendable and how connectable it is to the other zoo animals? I mean, that to me is the other amazing thing. It's just you can treat Kafka as nothing more than a data repo for streaming data, and you can do all sorts of enrichment, transformation, and model serving here as well, and push that out to Kudu, to Hive, to HBase. It's a really fantastic tool.
Well, the window joins that's late arriving data, or that those things in Flink, I think are what I love about it, right? In comparison to like doing something like that in Spark, which is micro batching, really, and you can't really do a window join in Spark, right? So
yeah, well, looking over windows without even replicating data, right? And then of course, that's from the ML side. If you're trying to look for something like in the ML space where you need a window of time, let's say you need 5 seconds or 5 minutes, having something like Flink chop that data up and serve it up is really powerful without making all those replications of that data. It's a very powerful tool. And of course, I'm a Star Wars fan. I mean, I love the fact that you can handle things in the way they actually arrive, or the way they were meant to arrive in that sense. It's pretty cool. Right.
Yeah, this is always a good analogy, man.
This one helps. Yeah. And this one is like, if you think about this here, I've got some computer science stuff for you all here on this. Let's see, LAN ports. When it comes to distributed systems, keeping event time is really important. And this goes back to computer science theory for the last 40, 50 years in distributed processing. But this is, if you obviously can look more into this, right? But this is the way to think about that. And this is where a lot of these principles come into play. Let's see if there's some good images on that. There's not a good image on that right now, but that's from that concept. That's where these things come from too, though. So it's just really cool. So as a computer science nerd myself, it's very cool.
Well, I guess if we have no more stuff, I guess we'll end it here at 8. It's a good time. We got a couple of awesome talks here. A lot of Flink and friends. We had people from all over the United States. Pretty cool. Hopefully the YouTube stream will be popular. I'll post that link later so everyone can share it. If there's anything, I'm going to see if maybe I can edit out that little blip of the Zoom bomb there. That was kind of annoying.
Yeah,
What are
it
you
was
gonna do?
interesting though.
Yeah, a little overly interesting.
Yeah, you wouldn't think a Flink meetup would be the most popular thing to Zoom bomb, but what are you gonna do?
I guess it must have been a slow night.
With a TikTok of streaming here.
Yeah, the hackers are restless.
Okay, I'm